Hi everybody, welcome back to another e-learning math day. Today's date is Monday, April the 20th, 2020. Our lesson for today is going to be patterns of equivalent fractions. And when you're finished here today, your assignment will be on IXL and will be assignment P10. So the work that we do today with equivalent fractions is really going to be looking at patterns, and I'm going to show this to you a couple of different ways. The first being with models, and then I'm going to end off with just showing you guys exactly how IXL will be set up today so that you guys are set up for success. So the definition of equivalent fractions is that fractions with a different numerator and denominator that represent the same value. So an equivalent fraction are two different fractions. They have different numerators, different denominators, but they represent the same value, the same total amount. So the first example that I'm going to show you here, and I'm going to show my comparison friend here too, I haven't seen him in a while, is the fraction 1/2 in comparison to 2/4. Well, what's different here? What's different between these two fractions? You might notice that both numerators are different numbers. I've got one of the pieces here. I've got two of the pieces here. Both of my denominators are different. My total is 2 pieces. My total is 4 pieces. And you may even recognize that the size of the pieces, the denominators, are different, which makes the actual cuts of the size or the pieces of this total different amounts. So I can use a model to help me solve a problem like this. Looking here, the fraction 1/2. Well, that tells me that I have a total of 2 pieces, 1 piece, 2 piece, and that one of them has been used. One of my 2 pieces has been used, and I'll represent that by shading it in. One of the 2 is used, one of the halves has been used. Same thinking here with the fraction 2/4. I have a total of 4 pieces, 1, 2, 3, 4, and 2 of them have been used. 1 piece, 2 pieces. And without having any mathematical background here, I can just recognize and look at these shapes that the amount of the 1/2 here and the amount of the 2/4 here represent the same value. They represent the same exact amount, which takes me back to that definition. Fractions with different numerators and different denominators that represent the same amount. So I can use my model here to prove it. So I can use multiplication when I'm looking to create an equivalent fraction. And it's possible to do this with any kind of fraction that I want to, as long as I'm following my biggest rule. Whatever I do to the top or whatever I do to the numerator, I must do to the denominator or to the bottom. I've got to do the same exact thinking here. So truly, you can multiply a fraction, a numerator and denominator, by any number that you choose. And just like we saw here with 1/2 and 1/4, it should be the same amount, however my pieces are just getting smaller and smaller. So let's take the fraction 4/5, and I'm going to multiply it, by 2. Okay? But whatever I do to the top, whatever I do to my numerator, I must also do to the denominator. So if I'm multiplying the top by 2, I must also multiply the bottom by 2. 4 times 2 is 8. 5 times 2 is 10. So what this tells me is that the fraction 4/5 and 8/10 are equivalent to each other. They are the same value, except my numerators and denominators are just different. They are equal. Let's take a look at 2/6. If I multiply the 6 by 3, I had better multiply the 2 by 3. Whatever to the bottom, to the top, whatever to the top, to the bottom. 2 times 3 is 6. 6 times 3 is 18. That tells me that 2/6 and 6/18 are the same value. They're the same amount. My numerators are just, and denominators are just a little bit different. If you guys remember from class, this could also look like something a little bit more sophisticated. Let me zoom in for us here. Up here, I multiplied by a whole fraction of 2/2. I can also, to save time, to save space, I can also go ahead and multiply 2/3. I can do a little baby times 2 and a little baby times 2. 2 times 2 is 4. 3 times 2 is 6. And I can prove that this works by the model that I've created for you here at the bottom, okay? My new fraction is 4/6. What I started off with, 2/3. Well, 2/3, if I shade in 1 and 2 of the 3 pieces, should represent the same amount as if I were to shade in 4 of the 6. 1, 2, 3, 4. Taking a look here, using my finger as a reference, 2/3, 2 of the 3 pieces, is equal or is the same to 4 of the 6. Okay, the last one I'll show you here is 5/8. Just one more time. Let's multiply this by 3. 5 times 3 is 15. 8 times 3, 8, 16, and 24. 15/24 is the same thing as 5/8. Today, when you're working on IXL, your math is really going to be mostly about finding patterns. So these fractions, as we move down the line here, you'll see that they're all equal to each other. I've just got to figure out what the pattern is here. So what do I notice so far about 1/2 being equal to 2/4 being equal to 3 something? Well, my numerators are in order, 1, 2, 3. Maybe look for a pattern here. Maybe I'm skip counting on my bottom. 1, 2, 3. Well, 2, 4. I've got a difference of 2 numbers here. My next one that I do here, let's see, 2, 4, 6. Skip counting by 2. Another way I could solve this pattern is by looking at the numerator to the denominator. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So my pattern here was either skip counting by 2's or multiplying the numerator by 2. Same kind of thinking down here. This one's a lot bigger. 2/5 equals 4/10 equals 6/15 equals 8/20 equals 10 somethings equals 12/30. Well, what do you notice here? I see a skip counting of 2, 4, 6, 8, 10, 12. I also see a change here on the bottom. 5, 10, 15, 20, 30. Well, skip counting by 5. 5, 10, 15, 20, 25, 30. So I can fill in those missing pieces here. The last one I'm going to have you guys do today will be our pause and try, and it looks just like this. Pause the video here and see if you can find out what missing pieces I have in this fraction. 1/6 is equal to 2/12 is equal to 3 somethings, equal to 4/24 equal to 5 somethings. I notice my numerators are in order, 1, 2, 3, 4, 5. I notice my denominators, 6, 12, something, 24, something. And if I know my facts here, 6, 12, 18, 24, and 30. So friends, today as you guys work on IXL, you'll really be filling in the gaps here and looking for patterns in your fractions. Good luck, you guys have it.